Section 2.2, the limit of a function. The limit of a function. So what do we have here in the limit of a function? This is really introduction to limits. What are limits about? And then just keep in mind, we're going to be using limits throughout the whole course. So if you can't get it now, it's going to be hard for you to move on with the course. For the limit of a function, so we have, I'm going to draw the xy plane like so. Let's say we have a function f with this given graph and pick a point A, x equals A. So A, if you project it up, it goes on the B on here, which is B. A and B, A and B. So what do we have? We are going to see as we approach the x equals A, where does the y go? Where does the y go? So if I pick a point here and then I project it up and then project it there, so that would be the corresponding y value. If I pick a point here and I project it up, that would be the corresponding y value. If I pick a point, project it up, that would be the y value. If you do it from the other side, from the other end, project it up, get closer, project it up, get closer, project it up. So what's happening here? As we getting closer and closer to A, the y is getting closer down this way. And as we come from the other side toward A, the blue thing is getting up. So in other words, as we getting closer and closer on the x-axis to A, the y values are getting closer and closer to B. If that makes sense. So one more time. As we getting closer and closer, so as we getting closer and closer to A, then the y is getting closer and closer to B. So here we got saying one last time, as we getting closer and closer to A on the x-axis, the y value is getting closer and closer to B. So to write that down, we say that the limit of f of x as x approaches A, okay, is B. That's what we just conclude here. As x get closer and closer to A, the y value getting closer to B. In symbols here, we're not going to keep writing this. We can write lim f of x as x approaches A equals B. Is that okay, guys? So if that's okay, I'm going to write an example here so I can show you how to handle this. Let f of x equals x squared plus 2. And the question would be, what is the limit of f of x as x approaches 3? Or like you can write like this, limit as x approaches 3 of x squared plus 2. What is that going to be? So as x approaches 3 means on the x-axis, so this is x and y, this is 3. And you got a function like, let's say like this. As you approach x from this side and this side, where is the y value heading? Is it heading to a point? What is that point? So you want to know what happens when you come or approach x from both ends, from the right side and the left side. So x approaches. So the arrow means approaches. So arrow approaches. That's what this means. So to do so, we pick values for x close to 3 and get the corresponding y values. Okay, so here we have a 3. We always put that number in there. We don't know what the y value is going to be, but we're going to get closer to that value. Say maybe somebody will throw 4 there, and then maybe 3.2 and maybe 3.01. Different people will pick up different values for x, but we will all get to the same result. 2.1 and then 2.6, 2.99. Do you see that? So these values are getting closer and closer to 3 from both ends. And then what happens if you substitute the 4 in here in the function, we get 4 squared 16 plus 2 18. If you substitute the 3.2 in, so 3.2 squared plus 2, that give me 12.24. If you substitute the 3.01, that's 11.06. And here you got 6.41. If you do it for this one, I got 8.76, and the last one I got 10.94. So now you're going to ask yourself, as we get closer and closer to 3 on both from both ends, where is the y heading toward? Which value you think? But you can look at the numbers, you can see it's heading. So as x approaches 3, the y values approaches 11. So we can say that the limit as x approaches 3 of x squared plus 2 equals 11. Any questions about this? No questions? While you're copying this, I'm going to write down the next one. So let's say estimate the value of the limit value of the limit as x approaches 0 of x squared minus 2x over x. So a student is asking, can we plug in 3 directly? The answer is no. Remember, this is not, I'm not saying calculate this at x equals c. We're asking you, as x approaches 3, what happens to the y value? Where is it approaching? It's approaching 11. And you will see graphically why we do it this way. When you are solving the problem, you should come up with the table yourself, not like it's going to be given to you. And different people, as I said earlier, will come up with different values for x. Maybe somebody will pick up like 3.7, 3.1, 3.001. That's totally fine. Every student will come up with different answers or different numbers, but the final answer will be the same. The values of x chosen will be different, but the answer will be the same. Anyone has any questions about this? If not, I'm gonna prepare the table for that. I'm gonna prepare the table. X and Y. So 0 goes in the middle here, and then try to pick bigger values and smaller values. So say 0.9 goes here, 0.4, 0.1, and below that I'm gonna pick -1, -0.5, and -0.1. What would be the y values? So make sure the values you choose are really close to the x equals 0. Like this is the 0 one. So you need to pick values within the neighborhood of 0. Like if you really want to pick better values, I think you should pick 0.1, 0.001, 0.0001. So the closer the values you choose, closer to the 0, the better. Okay, but if you pick like 3, 2, 1, I mean, you might not be able to end up with the answer you need. Okay, you might not end up with the answer you actually needed. So here, you can test one of these values just to make sure you know how I'm obtaining these values for the 0.9. So the 0.9, you can plug it back in here, 0.9 squared minus 2 times 0.9 over 0.9. And do that on the calculator, and you will be getting -1.01, the next one -1.6, the next one -1.9, and the next one here -3 I got, next one -2.5, and -2.1. So what do we have here? So the limit of x squared minus 2x over x as x approaches 0 is, what's the value? I see it as -2. Now, does it work out this way all the time? Like, does it really does it really come up with a point that, oh, I see it's really getting closer to that non-decimal number, like an integer, like -2 or 1 or 3 or 4? The answer is no. It doesn't work all the time like this. I can give you a quick one and you can try it later on your own. Estimate, if you try to estimate the value of the limit as x approaches 2 of, let's say, this function. Okay, so if you do it that way, that's not going to be an easy thing to, I mean, you can pick values for x, 1.999, 1.9, 1.8, and some values above 2, let's say like 2.001, 2.01. And then you will find out that the values are not approaching an exact value like an integer, 1 or 2 or 3. So then what we're doing is, what you find out, you can estimate, like I estimated and I found it's 1.1547. So if you come up with some answer on a test or homework very close to this, that's okay. We are doing kind of like estimation, not exact. So that's what a limit is about for now. This is what a limit. And then in section 2.4 later on, we will learn the precise definition of a limit. What is really a limit about? There's really precise definition for it. Here we're just telling you, what does it mean when you say you approach it, x approaches a number, and then what happens to the y value. So that's what I'm doing here. Now I want to introduce, because I've been talking about from the right side and the left side, those are called one-sided limits. One-sided limits. So if you try to find the limit of f of x as x approaches a from the right side, that's what a plus means. A to the plus sign, that means from the right side. And you find out that the limit has a value of L. And you find the limit of the function of x as x approaches a from the left side, and you got L as well. Then you can say that the limit of the function of x as x approaches a is L. So if you're approaching the function from both sides and they got to the same value, then the limit is L. So what about, as a note, let's say if the limit of the function as x approaches a from the right side does not equal the limit of f of x as x approaches a from the left side, then we say the limit of fx as x approaches a does not exist. What can be an example to show this? D and E means does not exist. L here, L stands for the value of the limit, like could be 2, could be 3, 2.7, just L for the value of the limit. So let me show you an example here on the graph. X, Y. This is the function. It's called piecewise function. The two pieces form one function called f. So if we try to find the limit of f of x as x approaches 0 from the right side, and the limit of f of x as x approaches 0 from the left side, what are we going to get? Well, when you approach 0, this is x equals 0. If you approach from this side, where is the y value heading to? So if you project it up or down, see, all the y values are what? Are 1. So if you approach from the right side, you will get 1. What about if you approach from the left side? You go this way. Where is the y value? If you project it up or down, you're hitting this line, which is -1. Notice they're not the same. So we can conclude here that the limit of the function as x approaches 0 does not exist. Why? Since the limit of f of x as x approaches 0 from the right side does not equal the limit of f of x as x approaches 0 from the left side. And I like to write a note here. What is f of 0? What is f of 0? F of 0 means when x is 0, what is the y value? It's 1, because at 1 it's closed circle. So originally this was a closed circle. At this one is an open circle, means there's no value there. If you project it up or down, it's going to only hit the 1, not -1. Next, I'm going to pick another or choose another example. Let's say we're given the graph of the function f, and we're asked to find the limit of f of x as x approaches 2 from the right side. The limit of f of x as x approaches 2 from the left side. And then find the limit of f of x as x approaches 2. And then we're going to find what is f of 2. We'll find all of these. I'll give you 3 minutes. You try it on your own first. And you can do it. So I see most of you answered, a lot of you actually answered the questions, which is good. So here, the limit for the first one, as x approaches 2 from the right side. So if you're getting closer and closer from this side, the y value is approaching 3. You know, that open circle in mathematics, in reality, it means something different. That open circle is very, very, very small, but we draw it like large so you can see it. So as you approach 2 from the right side, the y value is approaching 3. If you approach from the left side, also approaching 3. So what does that mean? So the limit is 3. But what's the value at 2? It's undefined. That's why when one of you asks me, can I just substitute directly? No, you can't. And this shows to you why. I hope that makes sense to all of you. Is that okay? I'm going to show you another example. You try. So I'm drawing a function here. Find 1, the limit of f of x as x approaches 4 from the right side. Find the limit of f of x as x approaches 4 from the left side. Find the limit of f of x as x approaches 4. Find f of 4. Try this one now. First one, the limit as x approaches 4 plus is 1 4 minus from the left side is 3. So this one does not exist, but this one is 2. I hope everyone got the same answer. Another example I prepared is to determine the value or values of a for which the limit of f of x as x approaches a exists. So what's the function? F of x equals 1 plus x if x less than -1, x squared if -1 less than or equal x less than 1, or 2 minus x if x bigger than or equal to 1. So this is a good one to try. The first thing I would like you to do is to graph this piecewise function by hand. Okay, and before we do this, a student is asking, can you explain what D&E means? D&E means does not exist. That's what it stands for. Does not exist. So for a limit to exist, when you approach it from the right side and left side, they should be the same. But since we got two values, 1 and 3, they are not the same. That's why we said does not exist. So does not exist since the limit of f of x when you approach it from the right side does not equal the limit of f of x when you approach it from the left side. That's what it means, does not exist. So now to this one. The first thing I want you to do is to graph this. I can give you enough time, and I'd like you to try to chat or share your information, not just final answers. Share some information. I did this. What did you guys did there? Kind of like group work over the chat. So now we move on. If everyone tried it, to graph it at least. So how do we graph piecewise functions? Important to learn this. The first one is a straight line. When x is 0, y 1. When y 0, x -1. But it says only below -1, means to the left of -1. Left of x equals -1. Next one is it's a y equals x squared function. When x is -1, y 1. And this is 1, so it's gonna go down this way up, but it only close to 1, not -1. That's the parabola. And the last one, when x is 1, if you plug in 1 here, you get 2 minus 1 is 1. So it really starts at this point. When x is 2, y is 0. So it's gonna go this way because it says only when x bigger than or equal to 1. Where does the limit exist? Notice the limit of the function as x approaches any number a exists everywhere except at x equals -1. Do you see why? Because if you try to approach the limit of the function as x approaches -1 from the left side or right side, it's not going to equal the limit. It's actually from the right side is 1, but that's not going to equal the limit of f of x as x approaches -1 from the left, which is 0. So at x equals -1, when you approach it from the right side, it goes up to 1. But when you approach from the left side, it goes to 0. Why the first and second graph is not a straight, it's not a line? The first one is a straight line. First and last are straight lines. Last one, the middle one, the second one is a parabola. Y equals x squared. Any questions about this example? For exams, you graph it and explain like you exactly the way I did it. Like where does it not exist? It's not exist when x equals -1. That's where the graph jumps. Like there's a jump in the graph. So now we continue with what about if we are given a function log x, if you guys remember this, how does the graph of this look like? This is the graph. Always keep in mind on any graph, there's always positive infinity, negative infinity, positive infinity, negative infinity in any graph. So the question is, if we are asked to find the limit of log of x as x approaches 0 from the right side. So if we give it a quick thought about this, from the right side means if you're getting this way, where is the y value heading to? It's not heading to a specific value. Where is it going to? It's going to negative infinity, right? It's going down. The y value is going down toward negative infinity. Right? Everyone can see why? Note, if the limit of f of x as x approaches c is plus or minus infinity, then x equals c is a vertical asymptote. We abbreviate with VA, vertical asymptote. More examples on this. Say we have the line x equals 1. We would like you to find, using this graph, find the limit of f of x as x approaches 1 plus, limit of f of x as x approaches 1 minus, and the limit of f of x as x approaches 1. So what do we get for this? For the first one, as you approach it from the right side, where does that head to? From the right side of 1, this way, where is the graph going to? It's going down, right? The graph is going down toward negative infinity. If we approach 1 from the left side, so then negative means left side. From the left side, the graph is going up toward positive infinity. So what do you think the limit of f of x as x approaches 1 equals to? What does that equal to? Well, this is going to be does not exist. Why? Since the limit of f of x as x approaches 1 from the right side does not equal the limit of f of x as x approaches 1 from the left side. Right? Both of them are different. One was negative infinity and one was positive infinity. That's why we say the limit does not exist. Right? Any questions about this? Any questions about this section? That was simply introduction to limits, what it means to say a limit approach x approaches 5 plus, 5 minus, limit does not exist, the value undefined.